Welcome to Inforce. Welcome to sunny Philadelphia. This is AWS Well-Architected for Network Security, featuring Mercado Libre. So, my name is Alpana Gulab. I look after a team of solution architects in sunny South Africa. I'm also joined by my dear friend Ash. He is a senior solution architect and based in Dubai. And we have our superstar, Mr. Kevin Goldsmith, who is the cloud security technical lead for Melli. Okay, so Melli, or Mercado Libre, if you have not heard of them, they are the largest online commerce and payments provider for Latin America. They operate over 18 different countries and have 144 million active users. So let's get started. Thanks, guys. Let's have a look at the agenda that we have planned today. We're going to do. We're going to have some discussions on the design principles of network security. Then Ash is going to do a deep dive into AWS Network Firewall and how the centralized inspection deployment model. And then finally, Kevin will take us through how Mercado Libre has scaled their traffic inspection, making use of AWS best practices. Okay, and I'll kick us off with a quote from our CTO, Dr. Werner Vodels, who says and confirms that at AWS, security is our top priority. He says that protecting our customers has always been our number one priority, and security has always been our number one investment area. We also know that organizations that have security at their core often are able to drive faster digital innovation and digital transformation. So here we're having a look at the well-architected framework. I'm sure most of us are quite familiar with it. It's made up of 6 different pillars, and it talks about design principles and best practices for architecting your workloads so that they are performant, so that they are reliable, so that they are scalable. And of course, there's the security pillar. So the security pillar focuses on increasing your security posture for your infrastructure and your services and your data using AWS services. Today, we're going to focus specifically on network security and how you can use design principles to be able to secure that network at scale. Okay, and when we talk about the security pillar, there's often 5 subcategories that we talk about, or 5 epics, as we call them, and you'll see they sort of tell a story. The first one is identity and access management. So here we talk about authentication and authorization. So making sure that users have the right level of access to the right resources. And then there's detection control. So here we talk about making sure that we can detect a security violation or security concern before it impacts your business. There's infrastructure protection. So your workloads that are running on your infrastructure and services, here we make sure that there's no security violations here. Then there's data protection. And here we talk about protecting data at rest or protecting data in transit. And doing this with access controls, doing this with encryption. Also making sure that data is properly classified according to the levels of sensitivity. Then finally, incident response. So no matter how mature your organization might be or how many security controls you have in place, you also want to ensure that there is a process in place for any potential violations or any potential security incidents. Okay, so what I'm going to do now, I'm going to dive into a couple of these. We'll talk about detection, we'll talk about infrastructure protection, and then Kevin will later talk about how they make use of these design principles at Melli. And let's start with infrastructure protection. So we know that security is critical at all layers. We have customers making use of AWS services for defense in depth with multiple security controls across multiple layers. From, for example, Amazon VPC that can be used to launch AWS resources in an isolated virtual network, to Private Link, where these resources can then connect to some supported services using private IP addresses. There's also AWS Network Firewall. Let's start with Firewall Manager, that can be used to configure and manage firewall rules across all of your accounts. Then there's AWS Network Firewall, which Ash is going to deep dive into just now. And that talks about how to deploy network firewall security across your VPCs. Great. And let's look at this now in action. Just a general example using best practices for infrastructure protection. So, of course, we'll start with the AWS account. And here you'll have a user that's accessing it, again, with the right level of access, having access to the right resources. And you'd use a service like IAM here, for example. So the first thing we'd want to do is create network layers. And of course, we have our VPC. And before we think of accessing our VPC, we'll think about the layers ahead of that, or above that. There's Amazon Route 53. That is our DNS service. And that can also be used to protect from DNS query flooding, for example. There's Amazon CloudFront, which can also be used then to protect from DDoS attacks. Then that can also be integrated with AWS WAF, which is our layer 7 firewall. Okay, then when we look inside of our VPC, we can have a load balancer, so an application load balancer to reduce the surface area of any potential attacks. Your NAT gateway for egress traffic. And then your application database, which again, according to best practices, you have within a private subnet. Okay, next we want to control traffic at all layers. So we'll do this with network ACLs, with security groups, with route tables. And then finally, I'll just mention implementing inspection and protection, making use of CloudFormation, making use of AWS Systems Manager, Session Manager to connect to your resources securely. Okay. Let's talk now a little bit about detective controls. So here, there's two parts here that we talk about or think about. Being able to detect unexpected changes or strange behaviors, or the other way around. Yeah, changes and strange behaviors. So here, we work with customers to be able to build end-to-end traceability. So making use of something like AWS CloudTrail, where CloudTrail tracks user activities, tracks APIs, and audits the entire AWS account and any changes that happen inside of that account. We'll also encourage things like VPC flow logs, application load balancer logs, and so on. I'll also mention here Amazon Guard Duty. This is an intelligent threat detection service, also continuously monitors and protects AWS accounts and workloads. The last service that I'll talk about with detective control is Amazon CloudWatch. This can be used to observe and to monitor your resources in your AWS account and also in your on-premise and in potentially other cloud environments. Okay, I'll talk about another example, another sort of real-world example, a network monitoring example, making use of, let's say, AWS Network Firewall, that is inspecting traffic going in and out of your VPC. So there's a couple of stages here. You'll see I'll walk through them. So first, in the collection stage, AWS Network Firewall does have built-in metric and log collection. So there'll be things like flow logs, which collects things like your IP address, source and IP addresses, source and destination IP addresses, things like different insights on those packets. So then in the next stage, the monitoring stage, we have, you can make use of Amazon CloudWatch dashboards here to then visualize those metrics. You can then also use those metrics to create alarms. I'm sure most of us have heard of alarms. And what happens here is you could set a threshold, you'd set a condition, and then a count of the number of times that condition is breached, or that threshold is breached, and then activate the alarm. There's different ways you can do this. You can be more proactive about it. So you can make use of CloudWatch anomaly detection. And what happens here is you'd have something called a width. And the width is just a band of an acceptable behavior. Going outside of that band, again, would be outside of your thresholds. You can, again, set an alarm to go into an alarm state. The last thing I'll also mention is you can use mathematical calculations on your metrics as well, so whatever suits you there. then. So we've done the monitoring, we've set the alarms. The alarms then trigger off different events. You can have, for example, you can trigger off an AWS Lambda function. You can have different custom actions. You can trigger Amazon EC2 auto-scaling, so you can scale your environment out, scale it in. Or maybe the simplest is just to have SNS notifications, send an email to all of your operational teams. Great. The last thing then I'll mention is an analyze stage. So you can use the logs that you've collected. You can use CloudWatch logs insights to then derive insights from those logs. You can search the raw logs. You can use contributor insights. So you can determine who your top contributors are, which are the top IP addresses that are connecting to your application. Great. So, okay, to summarize this section, I probably just want to talk about one or two things here. AWS is architected to be the most secure global cloud infrastructure. And of course, tons of benefits to making use of AWS, but there's two that I often like to mention. The first is customers that use AWS automatically inherit global security and compliance controls. The second is that at AWS, we have the largest ecosystem of security partners, and they are constantly building security solutions, iterating and improving on those security solutions. Okay, so using AWS, customers do have the comfort, they have the control to be able to build securely, to be able to drive their business forward, and to be able to build faster. Great. I'm going to move on to the next section now. We're going to dive deep into AWS Network Firewall and using this in a centralized inspection deployment model. To set the scene here, let's talk a little bit about customer strategies, customer solutions on what they do to secure their cloud network. So how they would integrate these solutions to be able to reach their business objectives. There's a couple of them here. The first is self-managed. So customers can have, here they'd have in-house tools that they'll build or develop. They can also use open source products, free tools here. There's third-party options. So they can use a virtual firewall appliance in the cloud. Then there's on-premise. So here cloud traffic would be directed from the cloud back onto on-prem for inspection on-prem. You can all in a co-location. And finally, cloud native. So these solutions would make use of AWS services, for example, AWS Network Firewall, network ACLs, security groups, so on. Now, as much as we've seen these strategies and the solutions, we've also seen some challenges. For example, when we think of on-premise, the on-premise solutions would require an organization to have quite specialized administrators, security administrators, network administrators to develop that code and also to maintain it. And over time, that can become quite complex. Then in a virtually deployed firewall, you can have some challenges where the software then doesn't fully integrate in AWS. You can have some scaling challenges there. So if you need to scale, you might have to use additional resources, which then is not very cost effective. Similarly, with data transfer, with on-premise, with making use of a firewall on-prem, you'd have to bring the data from the cloud back to on-prem. So again, data transfer costs not very cost effective. The last one, cloud native, there's even some challenges there. If you have an organization where your administrators are not very experienced with these tools, there can be a steep learning curve. Okay, so talking a little bit about cloud native. Here, the most common cloud native solutions are security groups and network ACLs. So let's address the question, why would we go beyond security groups and network ACLs? There's a couple of reasons for this. First, scaling challenges. We have, NACLs has, I believe, it has a limit of 40 rules. Security groups, I think it's 1,000 rules at maximum. So if a customer or if an organization needs to go beyond that, they then would need to make use of a different access point or different control point. Then there's inspection depth. So we know that NACLs and security groups function or operate on the network and transport layer. So if we need to do some sort of application filtering with parameters, application parameters, if we need to do, we need to look at filtering for HTTPS connections, we would have to make use of something like AWS WAF. Then there's centralized management. So here, if you have larger organizations, of course, we're looking at managing hundreds of VPCs across hundreds of accounts. So that can be a bit messy. It can become very complex. So again, you can look at using tools like AWS Firewall Manager to centrally manage all of those firewalls across all of your accounts. You can also have tools like AWS Network Firewall or third-party tools, and there you could use a centralized security team. The last one, business compliance. So here, some customers do have some business compliance that they need to, why they would need to go beyond security groups and network ACLs. Okay, now, how does all of this come together? I'm going to now hand over to Ash, and he's going to break that down for us. He's going to go through how network firewall can address or mitigate some of these challenges. Thank you.
Thank you, Alps. Thank you. Great. So before I get started with network firewall, I want to take it a step back to what we were talking about from a layered security perspective. So there's certain things that we need to think about when we start building our security. So we need to look at the traffic inside a VPC. We're talking about resources between subnets here. So usually customers use security groups and access lists there. We also look at the VPC boundary level. Now I'm looking at traffic that's going to leave the VPC, between VPCs in a region, multiple regions, and so on. And for that, I can use network firewall or any third-party appliance using and a gateway load balancer in front of it. And by the way, everything I'm going to talk about for network firewall, it can kind of apply the same for these third-party appliances with gateway load balancers. We also need to think about an application level protection, and that we use, for example, web application firewall. And something very important that Alpana mentioned, which is detective controls. So I need to build observability around my solutions, and for that I can use Amazon VPC flow logs. I can use traffic mirroring to have more in-depth inspection about my traffic, and how I can fit all this together across hundreds of accounts, VPCs, different security solutions. I can use Firewall Manager for that to automate all these deployments. So what is AWS Network Firewall? It's a managed service for a firewall solution that you can have in your AWS environment. It can be launched within AWS infrastructure, and you can build resources related to it within a VPC. So you can inspect the traffic between different VPCs, and it can be integrated with other solutions like Transit Gateway, Direct Connect, even VPN connections to inspect the traffic coming from all these sources and destinations. It allows you to create policy to block, filter traffic, and it gives you that monitoring capabilities. Like we were talking how we can use the metrics and logs that comes built in with network firewall to do deeper inspection. So network firewall allows you to do a lot of things, packet filtering, and there's a lot of things that you can do there. You can even now inspect encrypted traffic on TLS, and you can do these allow block lists for your traffic. It provides you with the visibility and reporting that you need for your network team and security team to have deeper inspection, to detect any security threats, and build automation on top of it if you want to remediate from these security threats. And what is more important, how to scale. Network firewall has this central management. You can even use CloudFormation scripts. You can use Firewall Manager to automate the deployment for policies across your accounts. So it gives you that cross-account management within an AWS organization, which what we want. We want to be able to scale with it. And that's why our customers are using it. We were talking about why to go beyond security groups and access lists. We want to do that more in-depth inspection on multiple layers. I need to do IPS, for example, IDS. I need to do filtering for my traffic for ingress and egress. And I want to have that capability to actually inspect any traffic within a VPC, between VPCs, in one region, multiple regions, and so on. And before going into the architectural perspective, let's talk about how I can do actual routing using network firewall. Like I mentioned, network firewall is a managed service. So the customers don't need to worry about scaling it. It scales as you increase the traffic. You don't need to worry about the infrastructure itself. And once you provision that network firewall, you start using it, right? But how I do use it? And we were talking about the concept of private link and the VPC endpoints. So when you want to send traffic to the network firewall, you will need to create a firewall endpoint inside a subnet in your VPC. And that can be in one VPC, multiple VPCs, and so on. In this example, you can see that I have a protected subnet, a private subnet, let's call it, and my workload sits there, and I want to send traffic to the internet. So I need to create another subnet for my firewall endpoint, because the firewall endpoint needs to be a separate subnet because it cannot inspect the traffic within that subnet. So that's something to keep in mind. So I will have one subnet for my network for my firewall endpoint. My workload is protected in a private subnet, and I want now to send it to the internet. So now, me, as an EC2 instance, I want to send traffic to the internet. My gateway will be that VPC endpoint. So I send the traffic. It will first hit that endpoint. The endpoint will inspect the traffic with the firewall with the network firewall. If it's allowed, send it back to the endpoint. And now I need to route traffic to the internet. For the subnet, for the network firewall endpoint, my gateway to the internet will be my internet gateway. So you can see that the routing is different between two subnets. So now I send the traffic to the internet gateway, gets into the internet. I can even have another layer there to put my NAT gateway, for example. And the traffic comes back. And here when I use a different concept, which is the internet gateway ingress route table. So I will have a separate route table for my internet gateway. For any traffic coming in, I can choose the destination where I need to send that traffic first. So in my egress route table, the traffic comes from the internet. My gateway to the subnet that I'm sending the traffic back to will be my VPC endpoint again, which is my firewall endpoint. So the traffic will be sent to the endpoint, get inspected with the firewall, and then if it's allowed, goes back to the endpoint. And the endpoint, the subnet there will have this route entry that will route all traffic locally within the VPC. So it will be able to send the traffic back to the EC2 instance. And this is how the path goes from the EC2 instance to the internet and back. Great. Cool. So now when we talk about using the network firewall, I can use it in different deployment model. And today I'm going to be focused on one of them, but let's talk about the three of them. I can have a distributed deployment model. And here, my VPCs, I don't need to send traffic between them. So I need to build security for each one of these VPCs. I need to filter the traffic in each one of them. I can have, for example, separate NAT gateways for each one of them, load balancers, and so on. Why do I need to do that? Because there's no communication between these VPCs. It can be isolated traffic, isolated applications. So I can create firewall endpoints in one of each these VPCs. This can limit the impact of any security threat, but at the same time, I need to think about the cost of managing all these resources. So I need to have a separate firewall for each one of these VPCs. It will process its own traffic and so on. So that can be an increase of cost and also management. So I need now to worry about all these VPCs. I can use Firewall Manager also to automate the deployment. Still, I need to think about every time I create a VPC, I need to have automation behind it to make sure that I have the security in place. And then centralized deployment model, which I'm going to be focused on today, and Kevin will walk us through also how they use that with Millie. And centralized deployment model, basically I will have my spoke VPCs, they all connected and interact with each other using the transit gateway, which is kind of like your virtual router within a region. It's a regional service. So the transit gateway will allow the communication between all these VPCs. I can integrate direct connect gateway to it. I can build VPN connections to it. I can integrate my SD-WAN connections to it as well. And I can centralize my security. How? I can build a separate VPC with my security services. I can call it an inspection VPC. That inspection VPC will have my firewall endpoint, and I can have my NAT gateway, for example, to it. So all my internet traffic, instead of building a separate internet route for each VPC, I can send all the traffic through the transit gateway, then to the NAT gateway in that inspection VPC. So that centralized management, it's more simple. I can integrate everything with one inspection VPC. I don't have that increase of cost for managing all the resources because all my traffic will be inspected by that one firewall. I just need to think about the cost of the transit gateway and the data processed through it. I can also have a combined deployment model. I might have some compliances where I need to have separate firewall for certain workload. So I can, for that, have a separate firewall in that specific edge VPC. And then I can have a shared firewall across the rest of the VPCs using transit gateway. So I can also combine the two. So now, there's a lot of traffic that I need to inspect, and I need to cover all of them, right? So I need to think about inspecting the traffic within a VPC, between VPCs in the same region, between VPCs across regions. I need to inspect traffic between on-prem and my VPCs. I need to look at ingress traffic from the internet and egress traffic to the internet. Let's go through them one by one in a centralized deployment model. So first, subnet to subnet. And this is cool because now we can even have a route entry. We used to have this local route entry for your route table for the VPC. So everything in the VPC is routed locally. But now we have the ability to actually have a destination for a subnet in that VPC to send it somewhere. And this is what I'm doing here. So I need to send the packet from instance 1 in subnet 1 to instance 2 in subnet 2. And here, I can have my local route, but I can also have a specific route. When I want to send traffic to subnet 2, I can send it to the network firewall endpoint, and the network firewall endpoint will inspect the traffic with my network firewall. After it gets inspected, the network firewall endpoint will route the traffic to instance 2 in subnet 2, and the same way in the way back. And this allows me to actually have that subnet to subnet layer inspection. Now look at it from a VPC to VPC. All the routings will be similar to the network firewall endpoint, but my gateway, how to connect to it, this is where I change things. So now I have two VPCs, my spoke VPCs. I need to send traffic between one to the other one. And because this is centralized deployment, I would have my inspection VPC with my network firewall endpoint in it. Now, all the communications needs to go through my transit gateway. So as a subnet in that VPC, my gateway will be the transit gateway endpoint. So when the traffic leaves the instance, it will first go to the transit gateway. The transit gateway, you can configure different attachments and different route tables with it, depending on the traffic where it's coming and where it needs to go. So the transit gateway sees the traffic coming from VPC 1. Before it sends it to a destination VPC 2, it will send the traffic first to the endpoint in inspection VPC, which will send the traffic to the network firewall endpoint for the traffic to be inspected. After it gets inspected, it will send it the same way to the transit gateway endpoint, to the transit gateway, send it through the other attachment to the VPC2, to the destination instance, right? And the same way in the way back. So any traffic that needs to be sent between instances between these two VPCs needs to go through the transit gateway to the inspection VPC and back. Same thing when we have two VPCs across two regions. But here I need to separate resources. Why? Because my transit gateway is a regional service. So I need to have one transit gateway to connect all the VPCs to it in region 1, and another transit gateway in the second region. And I can create cross-region peering between these two transit gateway. Right, so my gateway in region 1 to go to region 2, it's my transit gateway 1, and the same thing in the other region. And now, as I have two different sets of VPCs and transit gateway, I can create an inspection VPC in region 1 and an inspection VPC in region 2. So the traffic, when I need to send it from VPC 1, subnet 1, to, I believe I'm going to send it to either instance 1 or instance 2 in VPC 3, it will leave the subnet, it will go to the transit gateway in the first region, send it to the network firewall in the inspection VPC to be inspected, comes back, then the transit gateway will send it through the peering connection to the destination region. The transit gateway in the second region, before it sends it to the instance, it will also send it to the inspection VPC in the second region. Get inspected, comes back to the transit gateway, then to the destination instance. The same way in the route back. It will first be inspected in the region 2 with the inspection firewall via the transit gateway, then to the transit gateway 1 in the first region, get inspected in inspection VPC there, then to the destination instance. Cool. Same thing when we talk about on-prem to a VPC, because now I can have my direct connect between on-prem through a direct connect link to the direct connect gateway. That direct connect gateway, I can have a connection between it and the transit gateway. And then I can build that inspection between the two. So when I want to send traffic from my VPC to on-prem, my gateway to on-prem will be first my transit gateway. So the transit gateway will be my gateway to on-prem. The traffic will be sent first to the inspection VPC, get inspected, go back to the transit gateway. Then the transit gateway will send the traffic to the direct connect gateway. The direct connect gateway will send the traffic via my link to on-prem. The same way in the way back, the traffic will come back from on-prem through the direct connect gateway, connected to the transit gateway. The transit gateway first send the traffic to the inspection VPC, get inspected, and then back to the EC2 instance. Cool. Now let's talk about ingress traffic, right? So I have my VPCs. I'm going to have different applications running on multiple VPCs. I'm putting all these EC2 as a target behind a network load balancer, right? And I'm connecting these VPCs. First, I'm going to use transit gateway to connect these VPCs. And now, I will have a separate VPC for my firewall, which is my inspection VPC. And I will have two sets of subnets here. And also, there will be the subnet for the transit gateway endpoints, but it's not in the graph. But I will have it for ingress traffic. The traffic will come from the internet. I will have that ingress route table in the internet gateway. I will send the traffic first to the network firewall endpoint. And then I will have a set of application load balancers and network load balancers. And the target for it will be in a destination VPC. So the traffic will come back, just to show it again. Well, from the internet gateway, network firewall, I will have my first layer of application load balancer or a network load balancer. My target will be a network load balancer in a VPC, and the two VPCs will be connected using the transit gateway. So now I inspected the traffic before it even reached the destination. Instead of using the transit gateway, I can replace that with private link. So now I can minimize the cost. I can remove the transit gateway, for example, and I can use private link. And now that will allow me to connect the application load balancer in the inspection VPC to a destination in a separate VPC using private IP, using private link. And the same thing, traffic will come. I will send it first to the network firewall, get inspected to the first set of application load balancers, and then using private link to the target, which is a network load balancer in my destination VPC. When I talk about egress traffic, now I need to send the traffic from my EC2 instances to the internet. And now I'm using transit gateway as my central hub also to send the traffic. All my VPCs connected to transit gateway, so my gateway as an EC2 instance will be the transit gateway. The transit gateway takes the traffic and it wants to send it to the internet. So it will send it to that endpoint in the inspection VPC. And then I need to send the traffic through a NAT gateway. And here you can either put the network firewall endpoint first or the NAT gateway first, depending on when you want to inspect the traffic. So in my example, I put the NAT gateway first. I NATed the traffic. Then my subnet here for the NAT gateway will first send the traffic to the network firewall endpoint. It will be inspected with the firewall. And then the network firewall endpoint will send the traffic to the internet via the internet gateway. In the way back, it will use the same path. It will take the ingress route table, send the traffic first to the network firewall endpoint, get inspected, and then back to the instance. So now, you saw there's a lot of deployment models. I can have distributed deployment model. I can have centralized. I have combined. I can use security groups, access lists. I might be using WAF. And there's a lot of security services that I'm using now. And I need to scale it across a lot of accounts. How can I do that with AWS? And for that, we have Firewall Manager. And Firewall Manager is a central managed service that allow you to actually automate all this across all your accounts within an organization. And it integrates not just with network firewall. You can use it with your access lists and security groups. You can use it with WAF. You can use it with Route 53 DNS firewall. You can integrate it with third-party managed firewalls. And it allows you to automate the deployment for all these things across all your environment. You can even take the findings from network firewall, from Firewall Manager, and send it to Security Hub. And Alpana was talking about how we can actually build events on top of these things. I can analyze the findings from the Firewall Manager, from all the logs and metrics, and build automation to remediate from any security threats. right? So this all can be centralized and automated with these things. So just to recap, we were talking about why to go beyond security groups and access lists. Why do you need to do that further inspection with my data? Because security groups and access lists will allow me to have that first layer of security, but I need to have more deeper inspection between subnets within a VPC, between the VPCs in a region. I will scale to a different region. I need to think about how I also scale my business. So I need to inspect traffic between different regions when I start having cross multi-region deployment. I might have my on-prem resources as well that I need to connect to and inspect traffic between them for any compliance reasons and security needs. The same thing for my internet traffic. I need to think about the traffic generated to the internet and the traffic that I receive from the internet. And with that, I'm going to hand over to Kevin to take us through how they actually scaled all these best practices at Nelly.
Thank you, Ash. So, well, hello everyone. My name is Kevin Frachtenberg-Goldsmith. I'm currently working as a cloud security technical leader at Mercado Libre. I've been working in Mercado Libre for almost 6 years now. And today I'm going to talk how we scale traffic inspection, specifically on outbound traffic inspection. So the idea for this part of the session is to talk first about Mercado Libre scale. Then I'm going to introduce the different environments we have at Mercado Libre. I'm going to talk about the challenge that we wanted to solve, some metrics to dimension that challenge. And then I'm going to talk about the multi-environment solution that we came up with. And finally, I'm going to give some conclusions that we have. So, for those of you who don't know Mercado Libre is one of the biggest e-commerce and fintech in Latin America. We currently have 8 operations among 18 different countries. We have different business units such as Mercado Libre, which is the marketplace, Mercado Ads, Mercado Shops, Mercado Envíos, which is shipping, and we have the fintech part with Mercado Pago, with different business units too. And all of this is supported by more than 55,000 staff. Mercado Libre has been in NASDAQ since 2007. And we currently have 900 million requests per minute, distributed over 30,000 microservices. We have 19,000 daily deploys among more than 120,000 Amazon EC2 instances. And despite we are currently primarily on AWS, we are multi-cloud and multi-region. And over all those different cloud providers, we have more than 1,000 tenants. And this is supported by more than 15,000 employees in IT. So to talk about Mercado Libre's environments, I need first to introduce Fury. What is Fury? Fury is an in-house developed platform as a service or an internal development platform, which was meant to let the developers spend less time on maintenance and infrastructure and more time on product innovation. That way, they didn't have to spend time on the infrastructure or the services they needed to create those products and focus on the product itself. The Fury pillars are simplicity, security, availability, and scalability. In Meli, or Mercado Libre, we like to think our infrastructure as capabilities. That way we can create the products such as fraud prevention or credit suffering over those capabilities. These capabilities are such as observability, the different services as deployments, databases, builds, logs, the infrastructure itself, or the outbound traffic analysis and control, which I'm going to talk about now. Some facts about Fury and off Fury, as we call it. Both the environment on Fury and off Fury are multi-cloud and multi-region, but Fury has few but big accounts, and it only has predefined possible services. This means that the users of Fury can only use the specific services that are predefined on Fury. Some of them have very specific needs, and the predefined services that are on Fury are not enough for them, so they need to go off Fury. There is where we have more than 1,000 tenants distributed among 4 different cloud providers. So let's talk about the architecture before we introduce the the outbound traffic solution. In Fury, we have basically one Fury account with a single VPC, each with different availability zones, and each availability zone had its own private subnet with different workloads. The workloads send the traffic to a public subnet with a NAT gateway, and from there the traffic was sent to the internet gateway, and from there to the internet. On the other hand, we have many different off-Fury accounts, each of them which can have more than one VPC, and each VPC contains a private subnet and a NAT gateway on a public subnet, which send the traffic to the internet. So what was the challenge that we wanted to solve? We wanted to increase visibility and control on outbound traffic while reducing maintenance and management, having a multi-tenant perspective. This is primarily because we needed to support all the tenants we have on the different cloud providers, but specifically on AWS. To dimension this challenge, we have almost 300 terabytes per day in all regions, from which the 93% is only from Fury. The other 7% is off Fury. That is from AWS and other cloud providers too. So let's talk about the multi-environment solution. We basically divided the solution in 4 parts, starting with the traffic sources. Each of them is the off-Fury accounts on the Fury account. From there, the traffic is sent to the operations part, which are the AWS network firewalls. These network firewalls analyze the traffic and create the logs that are sent to the visibility part. And once the traffic is allowed, the traffic is sent to the internet. Finally, we created a rules API to deploy the rules and manage the rules through the AWS Firewall Manager, which deploys the rules to the network firewalls. Let's focus a little bit on the first part, the off-Fury accounts. So in the off-Fury accounts, we maintain the private subnets, each of them with their workloads and their VPCs, but now the traffic is sent through a transit gateway on a networking account, and from the transit gateway, the traffic is sent to the outbound traffic account in an inspection VPC, where the traffic is analyzed. There, the logs are generated in the network firewall, and once the traffic is allowed, it is sent back to the transit gateway, and from the transit gateway, it is sent to a central egress VPC, which is in charge of sending traffic through different NAT gateways to the internet gateway, and from there to the internet. Let's zoom in now in the Fury part. So in Fury, what we did was to basically inject a firewall endpoint between the private subnet and the public subnet. That way, the traffic is almost the same as before, but now the traffic is sent from the private subnet to a firewall endpoint. The firewall endpoint sends the traffic to the network firewall to be analyzed and to generate the logs. And then the traffic goes back to the public subnet and from there to the internet gateway. Let's talk now about the visibility part. So when the network firewall generates the logs, they are stored in an S3 bucket. And for each log, we generate an SQS notification, which triggers a task in an ECS cluster. And this task enriches the log using an enrichment API that we created, which basically has information about the tenant and contextualizing information that we use to analyze those logs furthermore, such as the source account, the owner information, and any other information we may use. Then the logs are sent to a centralized log monitoring section, so we can analyze the logs. Some of the things that we are doing with the logs analysis is entity behavior analytics. With this, we can identify missing VPC endpoints misconfigurations. We can use generative AI to detect suspicious or non-authorized destinations. We can create anomaly. We can use anomaly detection over total bytes by account. we can check for outbound traffic to unusual geographic locations, or check on over protocols and unusual ports. Another thing that we are doing with the log solution is the cost allocation. So before we introduce the outbound traffic solution, for each off-Fury account of each business unit, we have basically one VPC with a private subnet and a public subnet that had the NAT gateway. And that NAT gateway was the one that gave us the information on how much traffic they were generating. But now, we don't have the NAT gateway, and the traffic is sent through the transit gateway. So the way we found to allocate the cost to each business unit was using the enriched logs. With enriched logs, we can now know how much traffic is each business unit or each tenant generating, and we can allocate the cost to them. Now, let's talk about the rules API and why we built it. So the rules API can receive requests from different users, such as the incident response team, the generative AI, or any application or user that can generate rules. We store that rule in a rules database, and from there we send it to the cloud security account, where we have the firewall manager, which deploys these rules on each different network firewall that we have on each different environment, such as Fury or any other environment that we may have. Some rule examples that we have are like passing no destination TLS. We can drop any traffic that we don't know, and we can even block, for example, proxy avoidance and anonymized search tools. One thing to mention is that we can deploy each of these rules on a specific environment as we need it. We don't need to deploy all the rules on all the environments at the same time. So what about the multi-tenant part? We build probes. These probes are to respond to the question that the users or the owners may have, such as having, or the necessities that they may have, such as, for example, that they need to have a response time on their APIs within a limit time. They may say that the network firewall adds time to their response time, and they can have the network firewall. So with these probes, we can actually show them how much time we are adding to their solutions. On the Fury and off-Fury part, we basically created an ECS clusters, one that passes through the network firewall and that doesn't pass through the network firewall. And we basically measure the times of how much time we are adding there. We also created a probe with a transit gateway, with a cross-region peering with a transit gateway. And it basically goes from a region to a transit gateway with a cross-peering region to another transit gateway, and we measure those times. So just to sum up some conclusions or lessons learned. As Ash was mentioning before, we have alternative architectures. We may use different or alternative architectures, but they can have different. May come with different problems or solutions. For example, we can merge the egress VPC with analysis VPC, but we will lose the possibility to analyze east to west traffic. We also learned the importance of an asset inventory. The asset inventory is the one that has the information over the tenants, and is the one that the log solution uses to enrich the logs. Without it, we wouldn't be able to do the cost allocations that we are doing. Also, we learned that with this solution, we can detect misconfiguration and reduce cost. And the cloud-provided services also reduce management and maintenance and helped us to scale very quickly using, for example, the network firewall or the AWS network manager. That way, we can create new environments as fast as we need. And finally, the rules API is the one that helps us to use any firewall manager that we may want to use, And the rules API will be the one that will translate the rules that we need into a firewall manager language, let's say. So thank you everyone for coming today.